What if a robot could learn not just one job, but hundreds? Not hundreds of identical movements. Hundreds of completely different tasks. Packing boxes. Sorting parts. Using tools. Inspecting products. Working around people. Even adapting when something unexpected happens. Just a few years ago, that idea sounded more like science fiction than manufacturing reality. Today, Tesla says its latest Optimus humanoid robot is advancing faster than many experts expected. And that raises a question that could affect entire industries. If Tesla succeeds, are we looking at the beginning of a new labor revolution? Or are expectations getting far ahead of reality? Because despite all the excitement surrounding Optimus, there is still a major gap between impressive demonstrations and large-scale deployment. So what can Tesla's newest robot actually do? What remains a future goal? And why are investors, engineers, manufacturers, and competitors all paying close attention? Stay with us. Because the answer could reveal whether Tesla's biggest opportunity isn't a car at all. It might be a robot. When Tesla first revealed Optimus, many people were skeptical. At the time, Tesla was already trying to solve some of the most difficult challenges in artificial intelligence through full self-driving. Now the company was claiming it could build a useful humanoid robot as well. To critics, it sounded overly ambitious. To Tesla, it was the logical next step. Tesla's argument was simple. A self-driving vehicle and a humanoid robot share a surprising amount of technology. Both need cameras. Both need computer vision. Both need neural networks. Both need to understand the physical world in real time. And both require enormous amounts of AI training. The difference is that instead of navigating roads, Optimus must navigate human environments. That challenge may actually be harder. Roads are structured. Factories, warehouses, and homes are not. A robot must deal with objects, tools, people, obstacles, and unexpected situations constantly. And that's where Tesla believes its AI advantage matters. The excitement around humanoid robots isn't really about robotics. It's about labor. Around the world, industries are struggling to fill repetitive, physically demanding jobs. Manufacturing. Warehousing. Logistics. Agriculture. Construction. Many companies face rising labor costs and workforce shortages. If a capable humanoid robot becomes economically viable, the impact could be enormous. Imagine a machine that can operate around the clock. One that doesn't require specialized factory redesigns. One that can use tools designed for humans. One that can move through spaces already built for people. That's the promise behind humanoid robotics. Not just for Tesla. For the entire industry. But a promise is not a reality. And that's where the debate begins. To understand why Optimus matters, we need to understand how Tesla is approaching the problem. Traditional industrial robots are extremely effective. But they are usually programmed for specific tasks. Move here. Pick this up. Place it there. Repeat. Thousands of times. Optimus is attempting something different. Instead of being programmed for every possible action, Tesla wants the robot to learn. Just as humans learn. Not through instincts. But through experience. Tesla's AI systems rely heavily on neural networks. These systems analyze massive amounts of data. Patterns emerge. Predictions improve. Performance gets better over time. The same philosophy used in Tesla vehicles is being adapted for robotics. According to Tesla, Optimus can observe tasks, learn from demonstrations, and improve through training. That doesn't mean the robot understands the world like a human. Far from it. But it does mean the robot can become increasingly capable without engineers manually programming every movement. This is one reason Tesla talks about hundreds of possible tasks. Not because engineers created hundreds of separate programs, but because a general-purpose AI system may eventually perform many different activities using a shared learning framework. That's a fundamentally different approach. And also a much riskier one. This is where things become important. Many headlines suggest Optimus can already perform almost anything. That is not what the available evidence shows. Let's separate reality from speculation. Current capability. Tesla has demonstrated Optimus performing a growing variety of physical tasks, including object handling, walking, carrying items, and interacting with factory environments. Demonstrated capability. Tesla has publicly shown improvements in movement, dexterity, hand control, and autonomous task execution. Planned capability. Tesla says Optimus will eventually perform significantly more useful work across factories and other environments. Future possibility. Large-scale deployment across multiple industries. Potential household assistance. Potential service applications. Potential labor replacement in certain sectors. The key word is potential. Many of the most exciting use cases remain future objectives rather than proven commercial reality. Understanding that distinction is essential. If Optimus becomes successful, it could transform Tesla's business. Why? Because manufacturing robots may eventually represent a larger market than electric vehicles. Think about it. There are roughly 1 billion passenger vehicles worldwide. There are billions of workers. Tesla believes a general-purpose humanoid robot could become one of the most valuable products ever created. That's an extraordinary claim. But there is a business logic behind it. Factories need labor. Warehouses need labor. Distribution centers need labor. The demand is massive. The question isn't whether companies want more productivity. They do. The question is whether robots can deliver it economically. And that's where Tesla still has a lot to prove. Because building a robot is difficult. Building millions is far harder. Tesla is not alone. Companies around the world are pursuing humanoid robotics. Some focus on warehouses. Some focus on industrial work. Others focus on research. The competitive landscape is growing rapidly. Tesla's potential advantage comes from several areas. Large-scale manufacturing experience. AI development. Computer vision. Custom hardware. Massive real-world data collection. However, competitors also have strengths. Some have years of robotics experience. Some focus entirely on humanoid systems. Some already operate in industrial environments. This race is far from over. And the winner may not necessarily be the first company to build a robot. It may be the first company to build millions of reliable robots at a reasonable cost. What could go wrong? Quite a lot. Robotics is difficult. AI is difficult. Combining both is extremely difficult. A robot that works in a controlled demonstration may perform very differently in a chaotic real-world environment. Safety is another challenge. Reliability matters. Consistency matters. Trust matters. A single failure in a critical environment can create significant concerns. There are also economic questions. How much will the robot cost? How much maintenance will it require? How quickly can customers recover their investment? Until those questions have answers, widespread adoption remains uncertain. So has Tesla really created a robot capable of learning 500 insanely complex tasks? The honest answer is more nuanced than either enthusiasts or critics might prefer. Tesla has clearly demonstrated meaningful progress. The company appears to be advancing faster than many observers expected. Its AI-first approach is attracting serious attention. But the most ambitious claims still require proof at scale. The real story isn't whether Optimus can complete a few impressive demonstrations. The real story is whether Tesla can transform those demonstrations into a commercially viable product deployed across thousands or eventually millions of units. That challenge remains ahead. And it may be the most difficult challenge Tesla has ever attempted. Over the next few years, several milestones will be critical. Watch for increased factory deployment, expanded task capabilities, improved dexterity, faster movement, lower manufacturing costs, AI software improvements, larger production volumes, real-world customer deployments. Each milestone will provide valuable evidence about whether Tesla's robotics strategy is working. And if those milestones arrive faster than expected, the implications could extend far beyond Tesla. They could reshape manufacturing itself. Tesla Optimus may eventually become one of the most important products the company has ever created. Or it may prove far more difficult to commercialize than supporters expect. Right now, the evidence suggests meaningful progress. But not final victory. Tesla still needs to demonstrate scale, reliability, safety, and economics. Those are the factors that will ultimately determine success. The future rarely arrives all at once. It arrives one breakthrough at a time. And for Tesla, the next breakthrough may already be taking shape. If you enjoy deep analysis on Tesla, AI, robotics, autonomous driving, and the future of technology, subscribe to EV Insider. And now I want to hear from you. Do you think Tesla Optimus will become a true mass-market robot, or do you believe widespread adoption is still many years away? Drop your thoughts in the comments. I'll see you in the next one.